Okay, we will learn about evolutionary algorithm. Okay, what's in there? Evolution is more on evolution. Okay, we look over here. Okay, the objective of this chapter, okay, to understand how nature inspire evolution algorithm. Okay, and the foundation of evolution algorithm. What is the foundation to develop the evolution algorithm? And then the difference between genetic algorithm, genetic programming, and evolutionary programming. Okay, so for this video, we will tackle about genetic algorithm first. Okay, maybe in the next video, genetic programming and evolution programming. Okay, for this video, only genetic algorithm. Okay, first of all, we need to know what is the evolution algorithm. Okay, we are our natural. Okay, will be evolution. Okay, for example, this one. Okay, this bird. Okay, this the Chester, dia punya keturunan first. Okay, and then it will evolution based on what's the birds eating. For example, insect eating. Okay, this one insect eating, but wood picker type. Okay, insect eating and then seed eating. Okay, so it will evolution. Okay, evolution based on the environment. Okay, is capable of learning to predict changes to the environment. Okay, environment to other changes, so it will predict and try to adapt. So what is happen in the natural, right? This is the evolution. And then can evolution be intelligent? Yes. Okay, evolution can be intelligent because the evolution we apply, we learn, okay, and then we evolve, we try to improve, okay, based on the environment. Okay, so it can be intelligent. So the next is simulate evolution, okay, and then is series of optimization algorithm. Okay, we have many algorithm, so we need to find which one is optimized. Okay, which one is good, which one is better than another. So we need to apply optimization algorithm. Okay, and then optimization is iteratively improve. Dia akan iterates, dia akan loop, okay, the quality of solution until the optimal, sampai dia jumpa yang betul-betul optimum or at least feasible solution is found. Okay, jika if they are still have improvement, dia akan buat iterative, dia akan buat a loop lagi, try to improve, right, guna optimization algorithm. Okay, and then this based on natural selection and genetic. Okay, so dalam evolutionary computational we have three. Okay, genetic algorithm, I mentioned genetic algorithm, evolution strategies, and genetic programming. Okay, look over here, genetic algorithm, genetic programming, and then evolutionary programming. This one we will tackle. Okay, evolutionary strategy, ini kita tak tackle for this chapter. Okay, this one is the simulation of natural evolution. Okay, macam mana kita nak simulatekan natural punya evolution to our programming punya evolution. Okay, all method of evolutionary computational simulate natural evolution by first of all creating a population. Kita must create a population of individual. Okay, individual is mean over here. Kalau in term of apa yang what we need to get is the algorithm lah. Okay, because kita nak evolve our algorithm. Alright. Okay, and then evaluating their fitness, check their fitness. Okay, kita kena evaluate the accuracy and so on. Kalau algorithm, the accuracy, okay, and certain features yang lain lah, okay, yang kita nak evaluate. And then generating a new population. Okay, through genetic operation, okay, kita akan try to generate new population. Okay, lepas evaluate, generate new population, and then repeat the process. Lepas evaluate, okay, find yang the best, okay, and then try to generate a new population pula. Okay, dah check dia punya fitness, try to generate a new population. Okay, through genetic operation. Genetic operation ni boleh buat crossing and so on lah. Ada banyak nanti we will learn. Okay, and then kita dah buat genetic operation, nanti akan ada tambah lah. Kita ada yang dapat result from the fitness ni, yang the best, and then yang kita dah buat evolution, yang kita dah buat genetic operation, and then kita try to repeat. Okay, a number of time. So kita try banyak kali. Okay, so akan jumpa yang the best, yang best accuracy, yang fitness tu yang the best kita dah achieve, we will stop there. Okay, ini simulate from our natural evolution. Okay, in evolution algorithm analogy foundation, we have 4 individual. First, we need to know the term of individuals, and then selection. Okay, we need selection. Okay, and then we have this one, genetic operation, crossover or mutation. Okay, ini of their foundation, analogy of the foundation in EA, right? Okay, so you must know this term. Okay, genetic algorithm. What is the genetic algorithm? Okay, genetic algorithm is one of the in here right now. Okay, evolution algorithm. In evolution algorithm, we have genetic algorithm. Okay, over here. So we focus over here first. Genetic algorithm. Okay, genetic algorithm. What is the genetic algorithm? Okay, it's a search technique. Okay, search technique in computing to find a true or approximate solution to optimization. Okay, this is one of the technique. Kita nak search which algorithm is better than another. Okay, one of the optimization kita nak optimumkan kita punya result, and search problem based on biology operation evolution. Okay, look this one genetic algorithm. Okay, as you know, genetic we use a chromosome. Dia ada 2 chromosome chromosome. Okay, for example dalam chromosome we have gene. Okay, gene tu lah yang genes. Okay, genes tu yang menentukan kalau macam human rambut kalau apa and so on. Itu genes And then for this one, the introduce algorithm that manipulate string of binary digits. Okay, this represent chromosome consists of number of gene, and each gene is represented by 0 and 1. Ini gene 0 and 1. Okay, genetic algorithm. Okay, I mentioned you. Genetic algorithm use genes. Okay, and then how the step. Okay, in the genetic algorithm, the first one needs to represent the problem variable. Choose the chromosome population first. Okay, and then dia punya crossover probability and the mutation probability. Okay, and then define the fitness function. Okay, performance. Okay, fitness function apa yang kita nak pakai. And then step 3, random generate an initial population. Okay, kita generate initial population. This one is initial population of chromosome of size n. Okay, ni size n. Okay, kita dah populatekan semua. Okay, dalam satu population, initial population. And then calculate the fitness. Every chromosome. Okay, ini every method lah kat sini lah. Every algorithm tu, we check the fitness. Check dia punya accuracy and so on. Okay, check dia punya fitness, everyone. Okay, and then step 5, let's try to pair the chromosome for mating for the current population. Okay, and then kita try to make kan. Okay, kita can use the technique roulette wheel selection, rank selection, tournament selection. Okay, and then step 6, okay, create a pair of offspring chromosome by applying the genetic operation, crossover and mutation. Okay, kita try to pair. Okay, we have 2 chromosome. Okay, we try to pair kan. Crossover, kita akan crosskan dia punya genes ataupun kita akan mutatekan dia punya genes tu. Right? Nanti we will learn in detail about crossover and mutation. Then step 7, place the creation offspring chromosome in new population. Yang mana kita dah buat offspring ni, chromosome yang baru, a new one. Okay, kita dah buat crossover atau mutation, we put in the new population. And then, in the new population, we will repeat. Okay, repeat the step 5 with the same size until the size of new chromosome populate become equal to the size of initial population. Okay, kita akan cuba repeat sampai become equal size. Ini initial Initial kita tak berapa tadi, and then it must be equal. Okay, and 9, we replace the initial parent. We try to replace the initial parent chromosome. But for this one, we need to repeat. Okay, repeat. And then replace initial parent chromosome populated with a new offspring population. Kita replace. And then go to step 4 and repeat until the termination criteria is certified. And then go to step 5 or step 4. Okay, kat sini. Kita calculate balik. Repeat balik. Okay, dah generate. Kita find, kita dah evaluate, kita dah mutate, kita buat kat sini offspring. Okay, dah dapat new population. Yang new population tu, kita initialize balik, kita go through balik. Okay, until we come up with the termination criterion. Okay, mungkin maybe we meet the accuracy 90 and above. Okay, terminate. Okay, that's enough. Okay, this one is termination criterion. Okay, itulah guna genetic algorithm. It is using a genes. Okay, macam mana dia manipulate genes. Okay, in the genetic algorithm, crossover and mutation. Okay, this one tadi mana? This one mana? Ni, this one. Crossover and mutation. Okay, this one kita ada offspring kan, operator dia, and then it's like this one. Okay, we have crossover technique and mutation technique. And then in the crossover technique dia ada banyak variation lah. Okay, kita ada one off crossover, one point crossover, endpoint crossover, uniform crossover, order one crossover. And then for mutation kita ada, we have insert mutation, swap mutation, inverse mutation and scramble mutation. Right, maybe we go through one by one. This one is the crossover technique, one point crossover. Okay, if we choose a random point of two parents, okay, split the parent in the crossover point, create a child by exchanging tail, example in like this one. Okay, kita tengok this one is parent, dia ada two parents. This one is parent and then this one is child. Okay, ini child dia next generation yang new, yang kita dah produce new. Okay, ini kita separate. Okay, kita akan try to exchange. This one, put this one and yang one ni we put at above like this. Okay, kita cari one point crossover. Okay. Next is the 2 point crossover technique 2 and point crossover. Endpoint kita ada banyak point untuk crossover. Tadi just 1 point. This one is many point. This one kita akan cuba crossover. This one crossover is mean kita crosskan lah. Kita ada 2 chromosome, kita try to cross the genes. Okay, kat sini kita ada multiple point. Okay. Okay, this one is uniform crossover. Uniform crossover, we have assign head and tails, and then we flip a coin for each gen of the first child. Okay, first child we flip a coin. Okay, if hits one and then it's tail to another. Okay, we flip. And then let's try over here. Bila kita flip coin tu, jika ada hit, it will 1. For example, okay, this one is tail lah. Tail. And then the second child, okay, must inverse copy. That means kalau this one 0, this one must be 1. This one 1, this 0, 0, 0, this one must be inverse. Okay, 1, 1. Okay, yang kita flip the coin is over here. Yang first child tu. First child kita inverse copy. Okay, let's try. Okay, jika 1, 1. Ini dia secara random lah. Alright. And then we got the order 1 crossover. Okay, kita find the conservative alleles from parent 1. From parent 1 kita ada 2, 5, 8, 3. Kita find the conservative 2, 5, 8, 3. And then kita check the parent 2 ada tak the numbers of genes of the 2, 5, 8, 3 ada. This one. Okay, these four numbers. And then we mark out. Okay, and then we put the conservative genes tu, kita put in there, the child. Okay, so it will become 046, and then dekat over here, kita put yang kita mark tu, 25x3, and then continue with 971. So this one is the order crossover. Okay, and then we continue with the mutation. This one mutation, insert mutation, 21, insert mutation, we insert. Okay, 1, 2, 5, kita put it here. Okay, look over here, we put 5 in. Okay, please pick 2 allele value at randoms. Okay, pick a cell to follow the first, shift the long, accommodate. Okay, and then this one kita put the order. Okay, this one the order kita put in here, kita put kat depan. Okay, in front. So 1, 2, 5. Kita 3, 4 and kita continue lah 6, 7, 8, 9. Okay, we insert at the back and put in the in front. Or kalau depan tak belakang pun sama juga lah konsep dia. And this one is swap mutation. This one is swap. Okay, yang tadi kita insert, kita put it back and put it in the front, or at front to the back, and then this one kita swap. Okay, 2 and 5 where we try to swap. Okay, so 5 is in front and 2 at the back. Right, and then this one inverse mutation. We try to inverse. Okay, we select a portion. Kat mana portion kita nak address yang kita nak cuba inverse. And then we have select it and we try to inverse. Inverse kita balikkan lah. Okay, back to front, front to back. Okay, so this one it become 5, 4, 3, 2. Okay, and then this one scramble mutation. You just scramble. Okay, pick subset and random. Okay, dia akan rearrange at random. Okay, 2, 3, 4, 5, 2, 3, 4, 5. So dia akan rearrange ni dalam random lah. Tadi increasing ke apa ke. Tadi inverse, dia akan buat inverse. But this one in random. Alright. Okay, what is better? Crossover or mutation? Which method? Which one yang kita we use? Okay, it has been long debates for this one to produce which one is better. Okay, actually this one is depend on the problem. Okay, based on your problem. Okay, each method this one have their own advantages. Right, for this one kita tengok. Okay, untuk crossover obviously this one crossover can combine information because crossover we cross the chromosome. Okay, we from the two parents we try to cross. But in mutation we introduce a new information. Okay, because when we apply mutation, okay, kita try to play around, okay, mutatekan dia punya genes tu. Okay, not refer to another parent. Kita tak refer kepada parent. We put another information. Okay, maybe dia ada advantages and disadvantages. This one is to refer based on your refer to your project, your problem. Okay, this one is the pseudocode for genetic algorithm. Okay, first of all, initialize, macam step I have discussed earlier. Initialize and then evaluate the population. Every method yang dalam tu, video dalam tu, you need to evaluate. And then in over here, ini kita buat while, kan kita loop. Okay, dia akan produce a new generation and so on. Jika it's not meet a not certified the criteria, kita akan buat loop. This one dia put while loop over here. And then select parent for reproduce. Kita akan select parent. Perform crossover and mutation. Okay, try to perform crossover mutation and then try to evaluate the population again. Okay, and then kita buat akan, jika dia not meet the satisfaction criteria, okay, not certified the criteria, buat while lagi sampai dia meet the criteria. So dia akan terminate over here. Okay, ini dia punya pseudocode untuk genetic algorithm. Okay, for genetic algorithm, let's try find example, the case study for this one, for case study 2 about the travel salesman problem. Okay, salesman dia nak travel for each city. Okay, and then dia ada banyak city, needs travel. Which one, which set of cities, okay, will give the minimum total distance. Okay, one. Itu dia punya problem. Okay. Alright, for this one kita look over here. Kat sini kita ada London dan so on lah, Tokyo, Venice, Singapore and so on. And then dia akan buat city checklist 1. Ini dia buat. Okay, ini checklist. Dia akan pergi 3 dulu. Okay, Dunedin, and then 5, baru Beijing and so on. And then dia must go all of this city. Okay, and then city list 2. Okay, he go to Venice first and then baru dia pergi Beijing, okay, and so on. Dia akan buat dia punya list. Okay, and then dia akan fitness the fitness function calculate. Dia akan calculate the total distance setiap satu. Okay, that means setiap satu algorithm tu lah setiap satu this one, rule yang dibuat ni, apa yang dibuat, dia akan check dia punya fitness. Ni dia punya accuracy, we call it accuracy lah. Macam mana total dia punya fitness, kekuatan dia. Alright. And then we try to after we this one as a parent, okay, parent yang kita tentukan, and then we try to make a crossover. Okay, this one cuba kita crosskan from parent 1 and parent 2, try to crossover. This one, okay, kita akan crosskan. Okay, like jadi this one apa? 7 2, so dia akan replace, dia akan cross. This one dia akan crosskan. Right, 5 2 3 4 7 5. Okay, saya akan buat crossover. Okay, ini dah masuk ni lah. And then dia akan mutation, dia akan buat crossover. Ada yang buat crossover, ada yang buat mutation. This one dia buat mutation. Okay, dia akan replace and so on. Ini misalnya swap mutation. Okay, and then okay, ini staticities. Okay, this one ada staticities. Okay, this one solution I, contohnya for solution 1. Okay, for solution 1, okay, solution dia macam ni. Okay, and then this one is solution J. Okay, this one performance dia 941. Okay, ni jarak dia lah total. Okay, duration dia total dia punya distance, sorry, dia punya distance. Okay, and then this one this one is reduced for 800. Okay, solution 2, solution J, and then solution K is reduced to 652. Okay, so mungkin dia akan loop. Okay, crossover, dia akan buat crossover and so on. Dia akan produce a new one, and then dia evaluate dia punya fitness, so dia akan reduce for 652. Okay, and then dia akan buat loop lagi, try find generation, new generation, and buat fitness, check, evaluate the fitness, and then you got 420. Right? 420. Mungkin this one is the lowest lah. Okay, kita tengok lah. Tengok dia punya requirement. Requirement dia below 500, so dia akan stop sampai situ lah. Okay. Okay, ini dia punya generation. Ini sampai 100 generation. Okay, this one is best, worst, average, and so on. Okay, look over here. This one is dia punya distance. Okay, total distance. This one is dia punya generation. Okay, mungkin kita akan buat multiple generation. Okay, ada evolution and so on. So, dia akan ada total distance ni will reduce sampai certain generation. Nanti the mix over here, mungkin kita set over here less than 500, dia akan stop. Okay, based on our criteria. Okay, ni dia punya performance. Okay, quite good. Okay, what is the benefits using genetic algorithm? Okay, the concept is easy to understand. Okay, senang, dia akan ada evolution, try crossover and so on, easy to understand. Ada model separate for application, support multi-objective optimization, okay, and then good for noisy environment. Okay, mungkin ada banyak solution, so dia is the best lah. Right, and then always an answer. Always every yang dia come out tu always an answer, and answer is better. Tidak akan produce, evaluate, must be akan ada answer. Yang answer tu yang fitness yang the best. So yang the best tu yang better. So yang the better tu akan improve over time. Okay. And then benefits always speed and improve the GA based application, and then flexible building block for hybrid application, and substantial history and range of use. Okay, want to use genetic algorithm. Okay, bila kita nak pakai? Okay, when you have a alternate solution or too slow or overly complicated. Okay, complicated, and then you need to explore to examine a new approach. Ada new approach you nak explore. Alright, explore to examine a new approach, and then want to hybridize the existing solution. Okay, kita ada crossover tu kan. So dia akan hybrid lah. Okay, and then benefit of GA technology meet the key problem of requirement. Okay, ini when to use, bila kita nak pakai. Okay, bila you want to use genetic algorithm. Okay, some application type that using genetic algorithm. Okay, type application yang macam mana yang can be used okay, in genetic algorithm, okay, such as in control, domain control. Kita nak control the gas pipeline. Okay, kita contohnya pole balancing, missile evaluation pursuits. Okay, macam gas pipeline, okay, kita nak mana dulu, pergi mana and so on, the short distance, okay, dalam control punya domain. Okay, and then dalam design, okay, kita nak design, scheduling, kita nak schedule, okay, resource allocation, kita mungkin we have many ways and which one is better. Okay, so we can try using a genetic algorithm, robotics, okay, machine learning, okay, dalam machine learning, kita nak buat, nak classify, okay, and then the signal processing, okay, dalam signal processing ada filter design, okay, which one is filter first and so on maybe, okay, we put in front or the back, okay, filter, we produce a better result, okay, dalam signal processing, game playing, okay, dalam poker so on, and combination optimization, okay, adalah dalam salesman yang tadi kan, salesman, routing, big packing and so on, set covering and so on. Okay, ini contoh application that can be used in genetic algorithm to improve the algorithm. Okay. Okay, I have a video, okay, from the YouTube about the genetic algorithm. Is explains about the how the chromosome, genes overlap, crossover and so on. Is visually mungkin lagi nampak and lagi faham for more understanding, and then you can refer this video. Alright.
In this tutorial, I'll explain you genetic algorithm and how it is applied in case of traveling salesman problem, TSP. So you'll understand what is genetic algorithm, a graphical explanation of how does it work, a simplistic explanation of chromosome, crossover, mutation, survival of fittest through an example of traveling salesman problem, a pseudocode for application of genetic algorithm for TSP, and some practical tips for getting good solution. Let's start with what is genetic algorithm. In the last video, you learnt about ant colony algorithm, where it was trying to mimic the action of ants to find the shortest distance. Genetic algorithm is trying to emulate genetic evolution process to find solution. This uses chromosome, crossover, mutation, survival of fittest or natural evolution process to find good solution. The biggest advantage is that you don't really need to know how to solve for the optimal solution. You just need to know how to evaluate the quality of the solution, and through an iterative process you get good solution. There are two parts of this. Evolution and selection process almost remain same for all kind of problem. However, fitness function in chromosome design has to be very problem specific. Let's understand how does it work high level. So high level, you start with random selection of randomly generated K chromosomes, and this whole set is called population. So each chromosome actually represents an individual solution. So it is like this. This whole thing is population, and any individual is called chromosome. Then what you do? With K initial chromosome, through crossover and mutation, you create another K offspring. So here, this is an example of crossover. So what is crossover? If you look at, some portion of blue has gone into the red and some portion of red has come into the blue. So it's swapped part, and that's what is called crossover. What is mutation? So look at it, this is single chromosome only, but here this part and this part inversed its position, and that's why it is called mutation. Here there are not two chromosomes, there is just single chromosome. This is also an example of mutation because here one part you deleted. So that's how you became the another chromosome. This is how you create the K offspring chromosome. If you look carefully, it has those crossover component which has got created from the parents or got created through mutation. So now you have K plus K, 2K chromosome. So initially you started with K chromosome, then you had 2k chromosome, and using some kind of fitness function, you select the best k among them. So here you selected the best k. This process will repeat. So essentially this is here, and again you will repeat this process until the iteration threshold has reached. And these k that you have obtained at any stage are the most fit for the problem. To understand it better, let's understand through an example, and let's understand its term even better. So we are going to discuss this one by one. So let's first start with chromosome. So what is a chromosome with respect to traveling salesman problem? So if you remember, I talked about chromosome is a individual solution. So how do you generate individual solution in case of traveling salesman problem? Quickly recap of traveling salesman. Salesman has to start from one place, has to go to all cities just once, keep in mind just once, and come back to the original city. This is an example of a solution A, B, D, C, A, like A, B, D, C, A, or if you call it like 1, 2, 3, 4, 1, 2, 4, 3, 1 also, if you are representing A as 1, B as 2, like that. This is an example of chromosome. But how do you generate it for traveling salesman problem? And in case of traveling salesman problem, it is all about finding the least cost method. That's what is the fitness function. So you will all try to find out which is the least cost path, least distant path. So what you do, if you have 7 cities, you create a double array of size 6 like below. And then here first city field is random and second field is value like 2 to 7, very much like this. So here you have random numbers and here you have 2 to 7 in sequence. Now what you do, you sort this by random number. So then you sort, and this is how you get. So once you sorted 0.23 here, 0.34 came, and that's how 7 came here. Then 0.49, which is the fourth, came here. 0.585, 0.65 is bigger than 0.58, so 3 came here. And then 0.75, which is the biggest number, so 6 came here. If you look at this, has given you a sequence 1, 2, 7, 4, 3, 7, 4, 5, 3, 6, and then 1. So this is an example of a chromosome. You can repeat this process n number of times, k number of times, to get k chromosomes. What do you do after that? Let's understand crossover with respect to traveling salesman problem. If you recall, in crossover, I showed you that you swap part of this, and that's how you create crossover. However, this has to be done intelligently in case of genetic traveling salesman problem, because you don't want your solution to become invalid. So let me show you how to do it. So suppose this is one parent and this is another parent, and you decided this portion to crossover. So what you do in the first go, you remove 5, 7 and 6 from the below chromosome. So 5, 7 is here, 6 is here, you remove them and shift them one side. So you have 1, 2, 3, 4, that's here. And then you put 5, 7, 6 in any order, like you have put 6, 7, 5, and that has created a valid solution. So look at here, none of the cities is getting repeated, and crossover part can change its pattern. So 5, 7, 6 has come like 6, 7, 5, and that's okay, and it is a valid chromosome. Similarly, we can do for the other part also. Suppose you have taken 3, 4, 5, 6 here. So what you will do, you remove 3, 4 and 6, 1 to 5, 7 the string, and you will put it in some order like 4, 6, 3. This is another valid offspring. So from 2 chromosomes, 2 parents, you get 2 offsprings. Let me show you example of mutation with respect to traveling salesman problem. So how does mutation go? If you recall, I showed you inversion. So here the blue came up and orange came down. You can do that comfortably. What you can do, let's say you decided 4 to 5 as the portion which you want to invert. So what you will do, 5 has come here and 4 has come there, so it has inverted, and that's a new offspring. Let me show you one more example of mutation. So here what you can do, you can take a portion, let's say 7, 6, or 5 7, and you can put it here and shift everything right side. So 3 4 2 came this side, and that's another offspring. So that's how you do crossover and mutation. Now let me recap everything so that you can understand the complete flow, that how do you solve TSP. So what you do, you start with initial K chromosome. Let me take K equal to 50 so that you can relate better. So you started with 50 chromosomes, means 50 solutions. Then you generated 32 chromosomes through crossover, 14 chromosomes through mutation. So you have 32 plus 14, 46, and you generate 4 new random chromosomes, so that you always try to infuse a new kind of thing. From this, so you have 32 plus 14 plus 4, total 50. These 50 and the above 50, from 100, you try to get the best 50 chromosomes. So that's like survival of the fittest. And you update the iteration counter. So in the beginning, you will say it is 1, then 2, you have done it. If your iteration threshold is, let's say, 100, then you will repeat it till the time it is 99. So iteration count is less than threshold, you will go here and you will repeat the whole process. And if your iteration threshold has reached, then this is the solution. So it is not, so iteration is become equal to threshold. Whatever is the best solution, that you will say this is the solution. Let me give you some practical tips, because at times this doesn't find the good solution. So what you should do, what you need to understand, at times this approach may not be able to find good solution at all. Try to introduce some fast deterministic approach based solution as one of the initial solution, like Kruskal's minimum spanning tree for traveling salesman problem, that gives you very fast solution, and that's a deterministic approach, so that gives you solution quickly. Take thus that solution as one of the initial chromosome and then try to repeat it. Why I'm saying that? Because this way genetic will help you try to evolve a better solution if the above solution has not found the global minima. And many times this solution can get stuck to local minima. What you need to understand, even after this it can remain stuck to the local minima, but by this approach you have a higher chance of reaching to the global minima. What is local minima? Like if you look at, this is a local minima, in this whole vicinity this is the lowest, and then in this whole vicinity this is the max. So this is local minima, this is local maxima, this is local minima, but global minima is that which is the minimum of all local minima. And what is global maxima? Which is the maximum of all maxima. And that's what you want to achieve, but you can never be sure in case of those situations where you can't find all the roots. If you recall, that's what I had explained you in traveling salesman problem, the first video in this playlist. Please subscribe to my channel if you want to get updated what I'm updating, what I'm producing, and also hit the like button if you have liked this presentation.